All right, y'all, we are looking right now at day 3 of our topic 12 notes. And what we're looking at today, what we're going to start with is a review of a couple of terms that we're going to be using really throughout a bunch of topic 12. Okay, quick review. And that says this, we're talking specifically about this phrase, the measure of the arc. Okay, and what I mean by the measure of the arc is this: the measure of the arc is equal, I'll go ahead and highlight that so you fill it in your blank. It is equal to the measure of the central angle. Okay, so what I mean is that when you look at these two circles right here and right here, these two circles are showing you a picture of the same arc. Okay, and what we would say is that these are 70-degree arcs. Okay, so when we talk about the measure of an arc, it is talking about the measure of the central angle that's made by that arc. Okay, so when we talk about a 70-degree arc or a 138-degree arc or whatever it is, that's what we mean. Is we're talking about this angle down in the middle. Now then, with that out of the way, let's talk about a couple of theorems. Okay, the first theorem we're looking at, it says that congruent central angles have congruent arcs. Okay, what that means is that if this angle down in here, the central angle of arc AB and the central angle of arc CD, if those are congruent to each other, then that means the arcs themselves, arc AB and arc CD, are congruent to each other. All right? So we would say that AB with the little arch top is congruent to arc CD. Okay? That little arch top over the letters means it is an arc. All right, moving on to our next theorem. Congruent central angles have congruent chords. So it's not just the arcs that are the same. Okay, this one is saying that if you have angles that are the same down in here, it's not just arc AB and arc CD that are congruent. It is also saying that the line segments, the chords that connect AB and CD, are congruent as well. So this time we would say AB is congruent to CD, but this time instead of arcs, we're talking about line segments. AB is congruent to CD in that way. All right. Up next, we've got a third theorem that's related to this same idea, and it says that congruent chords have congruent arcs. It's actually just sort of a combination of those first two things. And this time we're saying that if these two line segments are the same, CD and BE, and we know they're the same because they both have one tick mark right there in the middle, since those are the same, this theorem is telling us that these arcs on the outside of them, CD and BE, are congruent to each other. So we would say that BE is congruent to CD. Both of those are arcs, so they get an arch top over them. All right, our fourth and final theorem for today is not quite the same as those other ones, but it does give us some helpful information. Okay, and that tells us that chords that are equidistant, that's our first thing to fill in, equidistant from the center, are congruent. Okay, congruent. Now we know what congruent means. It means that they are the same length. Okay, so here's what we're saying. If you've got two chords, I'm looking at chord BG and chord DC. And if these two chords are the same distance away from the center, if you drew a line straight from those chords to the center of the circle, it would look like this line and that line. And we know that those two lines that I just highlighted, we know they're the same length because they both have one tick mark right there. Since that is the case, it must be that BG is congruent to DC. Those two line segments, those two chords must be congruent to each other. All right, those are the four theorems. Let's look at an example that's going to use this. Okay, the example problem is asking what is the value of x? Okay, so there is a lot of things going on in this diagram. At first glance, this looks like a ton of information. And in some ways it is. And in some ways, really all you have to do is kind of puzzle piece together what does x line up with? What does x correspond to in this picture? And in doing this, in putting together those connections, we decide what is good information that's going to be useful for this problem and what is not going to be useful for this problem. Okay, so when I look at this right here, I can see that x is very clearly talking about the length of this chord right here. The distance in between B and A, that's the thing that we're looking for. Now, we can also pretty easily figure out that if we're trying to deal with X, we're trying to deal with that chord BA, we're probably going to be corresponding with this other chord, CD over here. Okay? That tells us that we don't actually care anything about this 3.2. 3.2 is not going to be part of the answer to this problem. Okay? All we need to know is that those two chords that I highlighted, chord BA up over here and chord CD down here, if they are the same distance away from the center, and we know that they are according to those tick marks that I just circled, this theorem that we just looked at says that if they're same distance away from the center, then they are congruent to each other. So let's talk about chord CD down here. This chord says that the left side of it over here, right there, that's 3.5. So that means this side over here must also be 3.5. And if we're talking about finding the length of the whole thing, which is what we're doing, then all we got to do is take that 3.5 and multiply it times 2. We know that the chords are going to be congruent, and we know that the length of the whole thing is just 2 times 3.5. Okay, so even though we started off with this complicated looking, busy looking diagram, the problem itself turns out to be really simple. Okay, the problem itself, when you get to the actual calculations of it, turns out to be very simple and easy. Okay, there's going to be a lot of problems like that as we move along through topic 12. So y'all just roll with me, okay? Some of those diagrams are going to look pretty crazy, but when you get to the actual problem solving part of it, it's not that hard, okay? So just keep up and read the questions carefully and make sure you know what is being asked of you, okay? That's all we're going to have for this section. So y'all have a good one.